Um, on this video, we'll kind of do um, the same thing that we have done um, when we are plotting this function um, x squared, and we also do it in the Octave. So on this video, we'll saw how to plot uh, x cubed. Okay, so is more of the same thing, and we'll just change the function. Right now is x cubed, and again, my goal is not to teach you how to do this um, mathematically, because again, it's something that you have learned on your high school days. It's very easy, very basic. What we wanted is to know how to do it with the Octave. We are trying to do better, right? Okay, so but first we'll try to do a scratch by hand, and after we can do with the Octave. So let's use the same points. So -3 cube is equal -27, and -2 cube is equal -8, and -1 cube is equal -1, 0, 1 cube is equal 1, and 2 cube is equal 8. And as you can see, this function is symmetrically but not mirrored. Or yeah, I think is symmetrically but not mirrored. Oh, you see that. 27. And now let me try to get more space to plot this. X, Y, which is the f of x. And let's see, 0, -1, -2, -3, 1, 2, and 3. Minus, let me see, -1, -5, -10, -15, -12, minus 25. Okay, so for minus 3, we'll get something like that. Minus 27. And for minus 2, we'll get minus 8. For minus 1, minus 1. Yeah, it is symmetrically but not mirrored. Or is inverse, is mirrored but not symmetrically. No, it is symmetrically but not mirrored. Right here is symmetrically. And it can be mirrored. And right here is symmetrically but not can be mirrored. So 1 and 5, 10, 15, 20, and for 2 is 8, and for 3 is 27. It goes to there. And here is where it leaves the problem, because the most points you cover, more better you can represent the function, and will not get so visible that this function is doing like a curve right here is passing to 0, something like that. And also this is very out of scale. I'm not being so precisely right here. And also because, again, my goal is to represent this with the octave, but this point right here, after pass to 0, where the function it changes its concavity, is where you have to pay attention, is where you have to do your analysis. Also, this is not a calculus video in which we can, if you were, we need to study something like the maximum and the minimum point that this function can reach, this type of things. Right here, we wanted to do plots in Octave. Okay, and right now, let's change right here for 3, and right here for -3. After, we can change these values of minimum and maximum. Again, line space is the function that will draw the x-axis, so we are attributing this function to the variable x that we are plotting right here. So we are plotting f of x, which is the function, that will change with the respective value of x's, and the number the points that we wanted that this function it got to be represented. Let's change right here for 50 and see the result. And also, like I said on the first video, in which we were plotting the function x square, we can, I don't know if I really said, but we got other ways to represent the x-axis. So right here, instead of use the line space function, we can also specify a vector, and a vector we can work with its length. Let me see right here. Let's try use this format, and if it doesn't work, we can changing again. Let's see, I'm going to make this a comment. Okay, and this will need to be a comment as well. Let's see what we'll get, and let's run it. And right here, of course, x cubed. Well, it doesn't work like I expected. So let me make this a comment just to see. Okay, let me see right now. Okay, okay, very nice. But look right here on the x-axis. It is going from -3 to 3, but for the y-axis, it is going to -13 to 30, -30 to 30. But I wanted that, well, is -17 to, sorry, is -27 to 27, the ranges of this function on the y-axis. Okay, but let me do something. And if right here it was square of 2x square, sorry, and yeah, but something that I wanted to do is limit this axis, so is x y lim, and I wanted to limit to the value that it is ranging. Okay, and but this is not working as I expected. Okay. Well, this is what I wanted to show to you with this video. Uh, we have do it for x squared and x cubed. So we plotted these functions in Octave, and you saw that it's very easy. And again, let me try this. I will just change this scale. Let's see if it works. I will do this as a comment. Okay. Um, so it's this way. Okay, that's it. For now, it's all, and hope you like it. Thank you.